Hey there guys, this is AdamantLife, and you have either accidentally or successfully navigated your way to episode 2 of my Python tutorial series, where we start out with kind of the bigger picture and then fill everything in between. So, you may recognize this guy from last episode. This is Jimmy. He's what we're using as a basis for our program. And to just recap what we have, here's what we have so far. We have 4 classes defined. And then we went ahead and went over a couple different ways that we can kind of attach the classes and create the classes. So that's where we left off, and I believe I stated that today we will be working on his backpack. So we'll go ahead and drag this over here. Backpack. Actually, you know what? Let's not do that. Let's use the text tool because I can't type with this. Or I can't write with this. Backpack. So basically, when we're thinking about, how this backpack is going to operate, I think we can all kind of agree that it's more or less going to work either as a table or a list. So either we're going to have, like ration, candle, caltrops, something like this inside the backpack. Or we're going to go ahead and have that, and then pair it to, 5 rations, 2 candles, 1 caltrops. So, we're going to go ahead and explore a couple different ways of implementing these. Basically, those 2 ways right there. And we'll do those first as a non-class, and then we'll implement them as part of the class. So I'll just leave that up there for now, and we'll hop on over here. So let's clear some of this out. So up here, I'm going to go ahead and add sword and shield here, and then we're just going to use this construction that we did here to create Jimmy all at once. And later on, I'm going to show you something else that we can do here to make this a little bit easier. Self.sword equals sword. Self.shield equals shield. And then sword equals shield equals. And then I'm just going to cut these over rather. And we'll get rid of everything else to clean this up a little bit. One thing you can do is these parentheses are kind of binding. So what happens is if we hit enter here and put this on a new line, normally a new line creates a new statement, right? But because it's within a parentheses, it will go ahead and just read it all the way through. That way we can have all this compact like this without having to, have to scroll over to see what's at the very end. The other thing you can do if there's not a parenthesis here is you can throw a backslash in there, and that will also continue the line to the next line. Generally not something you'll have to do a lot, and if you are doing it, it generally means that you're doing something wrong. But this is just fine for our purposes. So, again, right now we have Jimmy. He has a backpack, a sword, and a shield. And we've got to actually rearrange this because as you can see here, we go name, sword, shield, backpack. So let's just cut that, paste that down the end there, and then we'll go ahead and fix our white space here. Go like that. Alright, so everything's looking nice and pretty now, so we can get started. So the 2 things that we're going to talk about here, and these are going to be more the basic stuff that we skipped over to begin with and that you would have learned in a tutorial. Again, granted, a tutorial that goes over the basics of Python probably would have taken a lot longer for us to get to this topic because there's a lot of stuff to build up to it. But we'll be talking about lists and dictionaries. So as you can see here in the idle IDE, it highlights these as purple by default. You can technically change this kind of stuff, the highlighting colors, but there's really no reason to. So, in order to create a list, we're going to assign a reference to it, obviously. You don't always have to assign references, but we'll get to that later. And lists work kind of more or less how you expect it to. It's just going to take a whole bunch of stuff and throw them all together. There's going to be absolutely no kind of data verification or validation at all. So if you got a list full of both strings and words, words and numbers, then the Python isn't going to have a problem with that. Even if you have like classes, strings, numbers, dictionaries, lists inside a list, it doesn't care. It's just going to keep all that stuff bundled into the same list with absolutely no validation to it. So when we were talking earlier, we were saying, backpack, we may do as, a list of items. So very simply, instead of, well, we're not going to do this, okay? Just to start off with, we're going to use square brackets. Generally, when you're creating a list, you'll go ahead and use square brackets. The list function that you just saw highlighted there, that does something a little different. So in here, we can say, we had caltrops, I think, rations, and candles. That was the other thing. So this is one way to create a list. We have all those things in there, and when we read this list back, it's important to note that this is this exact order that these items are going to be in. So caltrops are always going to be read back first, then rations, then candles, unless we modify this list. So lists can also work kind of like queues, which means that, we can have a list of actions that have to be done, let's say, and then we can just kind of remove actions from the list one at a time. So that's another good usage of lists. So to show you a couple methods that we can do for this backpack, let's go ahead and just in the backpack part here, we're going to go ahead and type self.contents equals list. And this method now is going to create an empty list. It's exactly equivalent to doing this in this situation. In this situation, this is the same exact thing as typing list, like this. So we'll go ahead and do that. And down here now, to get us a little, instead of just adding everything at the start, we're going to go ahead and say self.backpack. And if we want to get to this list in here, by default, we can say, we'd have to say rather, jumping ahead of myself, Jimmy.backpack.contents. And then we can say append caltrops. And then if we print Jimmy.backpack.contents, and I'm going to go ahead and just run this really quick so that you can see it. You can see that it prints out this list with the square brackets and then caltrops inside that list. So we can see that's working right there. The other thing we can do is Jimmy.backpack.contents.extend. And what extend does is it, as you can see right here, extend a list by appending elements from the iterable. Idle doesn't always pop these tips up for whatever reason, but when it does, then you can verify. So an iterable is just something like a list. It's something we can step through. We're going to see other iterables, but for now we just know about lists. So caltrops, candles, and rations were the other things on our list. So I'll just go ahead and move this down like this, copy this down, and the next time we run this, we'll see the first time when we just did append, this was just append right here. We appended caltrops, and then after extending the caltrops list right here, we got a single list from the two that contains caltrops, candles, and rations. And again, these are the same exact order they were put in because this is a list. So I'm going to go ahead and close that out. Now, one thing I will note is that this, obviously, is really long and tedious. So what we're now going to do here is we're going to define a method. And we're going to go ahead and say append, because we know how to do that. Self, so this specific instance of backpack. And then item. And we'll go ahead and do it like that. And really simple, all we have to do, we'll go ahead and put a return in here. We'll return self.contents.append item. At this point, all we have to do now is say jimmy.backpack.append, and it will shortcut more or less. It'll say, okay, call the append method on Jimmy's backpack. Jimmy's backpack append method then says, okay, call the append method on our list called contents. So if you're seeing it steps through, Jimmy backpack append goes to here, and then this append goes to self.contents right here, and then calls this append method on self.contents, which, because it's a list, that's going to work. If for some reason self.contents right here on the backpack got replaced with something else that didn't take the append method, then this would actually fail and we'd get an error. But that should never happen unless somebody's really screwing something up. And then we're going to go ahead and just do the same with extend as well. Self. And I'm going to go ahead and do underscore list. You shouldn't do just plain list. You could do iterable, actually. That would probably be better. And then return self.contents.extend iterable. And again, at this point, this will let us get rid of this step right here. And we run it one more time. We can see we got the same exact output, but we used less code. And we also used the fact that we had objects with special methods to make our code easier to read. So instead of going, oh, jimmy's.backpack.contents, which is harder to read, and you're like, okay, what is contents? We get the idea intrinsically that Jimmy has a backpack, and this backpack appears to function like a list because it takes append and extend. So that's what we can do there. I will show you in a couple episodes a few more options that we can add to this to really make it function like a list, but we're going to leave it like that for now. We're just going to add things as we need them, and that will be fine. Now, I'm going to create a class called backpack2, and we're going to go ahead and make that one a dictionary, because like I said, sometimes, let's hop back over here, sometimes we like to have these quantities associated with the items that are there. So, hopping back to our code, this we're going to change to a dictionary. Now, a dictionary basically looks like this. Let me we'll leave that up there for now. So a dictionary is basically almost a list, okay? Almost. It's not actually a list, but it looks kind of similar to it. And then in this list, it's going to have a key, and then that key is going to be associated with a value. Basically, I'm going to go ahead and use the colon here. This colon is how we can create dictionaries if we use the curly braces. And then each key here, a key has to be something that can't change. So technically speaking, a string cannot change. So it can be a string or a word, in other words, or it can be a number, or it can be something else that just is incapable of changing. Technically, numbers you can't change. They just become other numbers and get replaced by it. And strings cannot change. They just, you'd have to overwrite the string and create a new string. So anything that cannot change can be used as a key here. And then the value can be anything you want it to be. So that even means that we could have a list as a value. We can have a list as a value. We can have another dictionary as a value. And as we go along here, we may end up seeing more options, more times rather, where maybe we want dictionaries inside of dictionaries. Times like that, it's going to almost be easier just to use a class, but it may end up becoming necessary at some point. So, Jimmy, we're going to go ahead and give Jimmy.backpack2 equals backpack2, and this will be a masterwork backpack. That's the name. So go ahead and class backpack2. It takes a name. I'm going to go ahead and give it the name masterwork backpack. Name equals, and then we close the parentheses. So at this point, Jimmy has 2 backpacks, and we're going to be working on backpack 2. So if you see me typing in backpack for the next 10 minutes, I'm screwing up, just in case you get confused. So Jimmy.backpack2. Now the way we assign a key to the backpack is by using square brackets. So in here we're going to go ahead and put, candles, or candle, we'll just say. We're going to spell it correctly though. Candle, again, that's a string that can't be changed. And then we'll go ahead and put the quantity of our candles in there, which, we'll say 5 candles. And then we can go ahead and do the same with other stuff. Backpack 2. Caltrops equals 2. Jimmy.backpack2. What do we have here? Rations 5, candles 2, caltrops 1. 2, 1, rations equals 5. Alright, cool. So now we have this backpack loaded up with quantities associated with it. So let's go ahead and print Jimmy.backpack2. We print that. We made a mistake here. So, again, we should be accessing Jimmy.contents. We haven't set this up to function like a dictionary yet. So, .contents. Whoops, getting a little ahead of myself. .contents. And we print. And there we go. Here's our backpack 1 up here. You can see we left it in the code down here. Right there. And then after adding all the stuff to it, we can see that rations, we have 5 of them. Again, this is the key here, the colon, and then 5 rations. Candle, 2 candles. Caltrops, 1 caltrops. And all is as it should be. So now we're going to go ahead and do the same thing we did up here, but it's actually going to be a little bit more complicated. And what we're going to do here actually is kind of beyond a lot of what you'd learn in a typical tutorial, but honestly, so long as you're following along just fine, shouldn't be a problem. So what it comes down to is that dictionaries, in order to do this thing where they use brackets and assign values or call values, they have special methods associated with them. So we're just going to have to set up those special methods so that we can get rid of this contents part right here and just call Jimmy.backpack square brackets, etc. And to do that, to get the item, in order to recall it, we're going to do self key, because we're going to use the key on the dictionary, and then return self.contents, and then we'll go ahead and just use it like we normally do. Self.contents key. Again, self.contents, that key gets replaced with, for example, candle. So candle comes in here, and then it just works on the dictionary like normal. Similarly, we'll go ahead and do a set item. Again, notice the double underscores. These are specialized functions that are really important and you shouldn't really be overriding unless you're implementing this kind of thing. Self key, keep my spacing consistent. Value, actually we can't do return here, so self.contents key equals value. You can't return an assignment like this where we got the equal sign in here. Fact of the matter is that an assignment generally returns none anyway. So we're just going to leave this as it is, and it will just naturally return none like normal. And then the other thing we'll do is delete item. So del item self key. And the way you would do that with the dictionary is you type in del, so any dictionary, self.contents key. And that will remove the key and the value from the dictionary. So if we did, Jimmy.backpack2, delete Jimmy.backpack2 rations, we would only have candles with 2 and caltrops with 1 left in the dictionary. It would completely get rid of rations and the 5 there that's associated with rations. So now we have the backpack 2 set up so that we can get rid of these content calls, and now we can just work directly with this backpack 2 class. Now I will note that we could do this anyway if backpack 2 and backpack 1 were just lists and dictionaries instead of classes. So the reason to have them as classes is to make other stuff that they can't normally do more intuitive. So what do I mean by that? Well, one of the things that we would normally want with a backpack, for example, is to know how much weight the backpack is. So I'm going to create a quick table here. It's going to just be a dictionary, and I'm going to call it item weights. Depending on how the program is set up, you may decide to implement this any number of ways. For example, these candles and caltrops and rations may actually be classes in themselves with weights associated with them, in which case this code would change a little bit. But we're going to keep it as simple as possible for the tutorial's sake. So I'm going to go ahead and send this up here because this is something that I want the whole entire program to know. So I'm just going to keep it at the top. So in here, I'm going to go ahead and put... Actually, I'll do this the other way. Since you've seen... I've already explained to you that doing this, and then a key, and then a value is a way to create a dictionary. And then we separate these with commas. Another key, value, etc. So I'll create the dictionary another way. You can also create a dictionary like this by doing dict, and then any keys in here, so long as they are viable words. So I'm not going to bother bringing up an example. It's something you'll run into and figure out really quickly. But so I can just do candle, and I don't need any quotes, equals candle weighs like 0.1, let's say. Rations equals 0.5. Caltrops equals 0.2. And now I've created a dictionary. And that's the other way of creating a dictionary. So what we can do now is we can say define get weight. So now I'm going to go ahead and move this up because when you're organizing code, you kind of want code organized in a way that makes sense. So these special methods that we have here that emulate, make these classes act like lists and dictionaries. I'm going to go ahead and just keep them separate from the rest of the methods that we're using. Self.getWeight. And we're going to go ahead and just leave it like that. And furthermore, I'm going to actually create this method out here just because it's something you should keep in mind, okay? Remember that I'm putting this in here to make it more convenient to call get weight off a backpack, but it may not be something that the backpack itself may necessarily have individual, so it may be useful to make get weight out here as its own function. Actually, you know what? I'm sorry. I didn't think this went too far out. We're going to do get list weight, and then we'll have the list, and then we're going to have another function, get dict weight, and we're going to keep it simple like this. There's a couple different ways that we can work through this, but we're just going to keep it as simple as possible. So what we're going to do here is return. Actually, I haven't taught you list comprehensions yet. We're going to go ahead and say that for next episode, list comprehensions, and we'll replace this code that I'm writing right now. I am going to have to teach you iterations, though, in order to get through this. So that's more or less in line with what we're doing right now, so I don't feel too bad about that. So we're going to say starting weight equals 0. So we're going to start with a 0. And then iterations. So I said I mentioned this thing called an iterable. Lists are iterables, as I demonstrated down here when we extended the backpack, the normal backpack 1, with this list itself. So for item in list, again, this underscore list here is what I'm calling this variable here. And then what's that going to do is a for loop. That's called a for loop right there. It's for blank in iterable, okay? Colon, and then enter and tab in. Okay, that's how we set it up. So it's going to take this iterable and it's going to try to step through. However that iterable works determines how it's going to step through. So we can go ahead and step through a dictionary next. We'll do the same format for the dictionary, and you'll see how that differs. For a list, that's just going to return the item at each index. So when we've got this whole entire list that goes caltrops, candles, rations, right? This is the 0 index because indexes start at 0 in programming. So 0 index, first index, second index, just goes through in that order and returns whatever is there exactly as it is when you iterate through a list. So this is going to return, I'll go ahead and comment this here, returns the item in the list. And that's going to be a string. We're expecting that to be a string. So what we're going to do with that is we're going to feed that string from the list into this dictionary here as the key. Let me just make sure that I have these spelled correctly so that we don't run into any key errors. So candle, rations, caltrops, candles, ration, caltrops, candle, rations, ration, caltrops. There we go. So we've got all our S's in line. And then we're going to say starting weight. Let's actually just, again, keep this as simple as possible for you guys. Weight equals item weights. And then to get the value out of the dictionary again, we're just going to use the square brackets. This item here, as our memo right here states, is going to be a string. So we're going to plug that in as the value right here. So the first thing we've got in this list right here is caltrops in backpack 1. The first item in backpack 1 is caltrops. So it's going to say item weights. It's going to look for caltrops and then return the value associated with caltrops, which is 0.2. So now we have the weight of our caltrops. And then we're going to go ahead and starting weight equals starting weight. So we want it to be equal to what we had plus the new weight of the item. So when we go through caltrops, now our weight's going to be 0.2 because it's going to be 0 plus 0.2 for a 0.2 total. And when we go to, what's after that? Candle. So candle's next. So that's going to be 0.1. So we're going to have a starting weight of 0.2. So starting weight 0.2. Our weight from looking this up is 0.1. So 0.2 plus 0.1 is going to be 0.3. And then when we get to the ration, that's going to be a 0.5 in this weight right here. 0.3 plus 0.5 is going to have 0.8. And then we will return starting weight, because that's going to be the sum of all the weights that we've gotten through this item weight function right here. So there we go. That's a real simple way to get the weight of our backpack by iterating through a list and feeding that list into a dictionary, which we just learned about, and then adding all that together. Okay, yeah, I'm going to just go ahead and do the dictionary one here. I was kind of trying to figure out whether or not I wanted to save this for next time, but there's another little trick I'll show you to make this a little denser. So we'll do the same thing. Starting weight equals 0 for item. Well, actually, yeah, I'm going to do it this way. Again, there's a million ways to skin a cat, but we'll go ahead and keep it simple for now. For item in dict. So when we iterate through this dictionary, which happens to also be iterable, what we actually get out doing it this way, doing the basic way, is the keys, and just the keys. We don't get these values, or down here rather, these values. So all we're going to get is candle, then caltrop, then rations. So we'll make a memo there. Returns the key in the dictionary. And that's going to be a string. One other thing I will mention is dictionaries are not ordered, which means that we may run this one time and we'll get rations out first, and then candle, and then caltrops. We may run it another time, get caltrops, then candle, then rations, etc., etc. Dictionaries are not ordered because they're lookup tables. So the order actually doesn't matter. Most of the time, if you need an ordered dictionary, you actually don't. I'm going to say that. So you may sit there and say, oh man, I really need to have these things in order. So I'm going to need an ordered dictionary. And there is such a thing as an ordered dictionary. But chances are you can just write your code differently, and you don't even need it. So keep that in mind. So for item in dict, yes, we have our starting weight. So I'm going to shorten all this up here that we just learned into a single line. So starting weight, so whatever that is at the time, which for the first time through, for the first item that this dictionary randomly pulls out, is going to be 0. And then the second time is going to be whatever the weight was from working with the 0. Starting weight plus equals. So what this means is whatever is right after this equals sign, it's going to be added to the starting weight and then assigned as the starting weight. So that is what is happening here. It is doing starting weight plus weight equals starting weight. So that this is rewritten as comment it starting weight plus equals weight. Now we're going to go ahead and shorten this up even more by replacing weight with item weights item. So instead of having two lines here where we have weight, item weights item, starting weight plus equals weight, we're just going to put that all on one line. Item weights item. I will take a moment to say that if your code doesn't make any sense, if it's so convoluted that it's really hard to read, then you actually should stop and just back it down to whatever is simplest to read, because what's important is getting the code done so that you can start fixing stuff. Optimize, like even this level of optimization where I go from 2 lines and this line's kind of long to a single line is so microscopic of an optimization that you really don't need it. Like, this should not impact anything right here, being here or here. This is just easier and quicker to write, is the only reason I'm showing it to you. So if this doesn't make sense to you, if you're having a hard time doing this, don't worry about it. Just do it this way. So now that we have that out of the way, we have managed to get this down to 3 lines. Next time, I said I'd show you how to do it even tighter. So with list comprehensions, so you can look forward to that. Problem here, okay, as I'm staring at this. Item gets us this weight right here. So if we're put candle in, we're getting 0.1. But that doesn't include our quantities. Now it doesn't. So what we're going to do is we're going to put a asterisk right here, which is the symbol for multiplication in Python. So asterisk for multiplication. And then we will go ahead and put dict item. So what this calls, this goes into the dictionary, puts item in. So if it's candle, it puts item into the dictionary and gets back 2. So now we have 0.1 here times 2 for 0.2 all together. And then we add that to the starting weight. If that, is a little complicated for you, I'll go ahead and write it out. Item weights item equals 0.1, I believe we decided. Yeah, candle of 0.1. I'll just memo that. Candle. Example. Dict item equals 2. And then we've got 0.1 times 2. Starting weight plus equals 0.1 times plus 2. So that's what these two things resolve into. And then, just to make sure you're following along, this resolves into equals starting weight plus 0.1 times 2. And there we go. So all this is condensed in one little line, which makes it quicker to write, and so long as you're familiar with the language, easy enough to read. So we are done here. We've got all this stuff in here that we needed, so we can just return starting weight. And now we're good. So when we do get weight here, what we can do is return get list weight. So we're going to, just like we are returning a method that belongs to something else, we're returning this method up here, and this list right here is just going to be, where are we? There we go. Self.contents. And the same exact thing down here. Define get weight self return self dot or return get dict weight self dot contents. So we're passing in both of these situations whatever our contents is, which is a list up here, and this requires a list. This method is a dict right here, so we use the function that requires a dict. And I will go ahead and put a space there. And now we can come down here, print Jimmy.backpack.getWeight. So now we can find out how much each of Jimmy's backpacks weigh. Backpack2.getWeight. And you can see these things, to note, could have been something like get weight Jimmy.backpack.contents. All this gets replaced by a simple call to get the weight off of Jimmy's backpack, which makes sense logically because we don't want this random list. That's not what we're thinking about. We're not thinking of the backpack as a random list. We're thinking of the backpack as an item, as an object. And then we should be able to, that object should be able to tell us what its weight is. I mean, we could go even further, for sake of the argument and say, starting weight, we're replacing all this, starting weight equals 0, etc., 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 and replacing each line with, Jimmy's backpack. We're saving a heck of a lot of space by doing this simple Jimmy's backpack.getWeight. So let's run this really quick. Make sure I didn't screw anything up. No errors. We can see that backpack 1 only had 1 of each item in it. Therefore, it's a lot lighter than backpack 2, which had 5 rations, 2 candles, and 1 caltrop. If we want to test that math really quick to make sure this is what we have, that's 5 times 0.5 is 2.5. 2 times 0.1 is 0.2. So that's 2.7. And then the caltrops was 0.2. Yeah, 0.2. So hopping back over here, 2.7 rather plus 0.2 for the caltrops is 2.9. This is a random rounding float error. Okay, normally this isn't going to affect anything. It's so far out, especially for our uses. But if you're going to be doing some kind of scientific stuff, that's something you're going to need to be aware of. Because I've never had to deal with anything this specific, I actually can't tell you off the top of my head why it is. Possibly because I was multiplying an integer by a float. The 0.1, the 0.2s were floats, and this is an integer. So maybe if I had done 5.0, there we go, 5.0 times 0.5, that wouldn't have gotten us that random 0.4 at the end. Like I said, it's not going to matter at all. So, when you output this information, just for the record, you probably are going to want to format it in some way. For example, screw it. I'm not going to worry about it. Just know that when you output information to the user, most of the time you want it looking a specific way, is what I was basically going to say. In which case, they're never going to see these trailing zeros and fours anyway. You'll have this looking exactly how you want it. So it could be like 2 pounds, 0.9, or, you'll convert this into ounces, that 0.9 into ounces. So you'll say like 2 pounds, I guess that's like 14 and a half ounces or something like that. And then that's how it will look to the user, and they'll never see this trailing 4, so it's really irrelevant. So that wraps us up for episode number 3. We learned quite a bit this episode, so if you need to think about it some more, feel free to spend some extra time playing around with the language and building your own stuff. Otherwise, like I said, next episode we'll start talking about list comprehensions, which are both fun and often unnecessary. There are times when you'll want to use a list comprehension and then you'll just realize, I probably shouldn't be using list comprehension right now, but they're fun, so that's going to be an enjoyable experience. And I'll figure out something else, because that should be a relatively short lesson, so I'll figure out something else to add on. Actually, I'll probably do keyword arguments next time. So, keyword arguments and list comprehensions. Thank you for watching. Like, favorite, subscribe if you please. Have a wonderful morning, afternoon, or evening, wherever you're at in the world, and I'll catch you later.